Hi students, this is Professor Gina and I am going to show you a couple of examples from the worksheet on finding the volume of irregular shapes. So I'll start with this one that looks sort of like a pill. It's a couple of shapes put together. This part that's in the middle is like a cylinder, and then the top and the bottom are both going to be half of a sphere. And so if we think about, if we think about taking the two half spheres and putting them together, we would have one complete sphere. So I'm going to think about the volume of this as a cylinder, which is in the middle, plus a sphere, even though it's split into two pieces. The volume of a cylinder is the area of the base multiplied by the height, and the area of a sphere is 4/3 pi times the radius cubed. So I'll kind of look at these two separately. So let's start with the cylinder first. The base is a circle. And so the base area is pi r squared, or in this case, the radius is 6. So that would be 36 times pi. And the height is 11. So I think that the volume of the cylinder is going to be the 36 pi multiplied by 11, which is 36 times 11, 396 pi, or if I multiply that by 3.14, I get 1243.44. All right, let's look at the sphere next. The volume of a sphere is 4/3 pi times the radius cubed, or 4/3 pi. The radius is 6, so times 6 cubed. That ends up being 288 pi. If I multiply 288 times 3.14, I get 903.32. And so then if I add these two items together, that'll give me my total volume. Which is 2,146.76, and the units are meters, so meters cubed. All right, so that's our first example. For our second example, we're looking at, it looks like a rectangular prism, and it has half of a sphere or half of a dome sitting on top of it. So my total volume here is going to be a rectangular prism plus 1/2 of a sphere. The volume of the rectangular prism is length times the width times the height. And then for the sphere, we have 1/2 multiplied by 4/3 pi r cubed. Right, so we'll do these in two separate parts. For the rectangular prism, the volume is 8 by 8 by 12, which is 768. For the half sphere, we have 1/2 times 4/3 times pi. And then the radius is going to be half of this distance here. So it looks like it's going to be 4, right? So I think it's going to be 4 cubed. So this ends up being, hang on, 4 divided by 2. I think we get 128 over 3 times pi. Let me just double check that. Oops, hang on. 4 to the 4th. Yeah, 128 over 3 times pi. So putting these two together here, I have that the total volume is 768 plus 128 over 3 times pi, which is going to be approximately, I'm going to put 3.14 in for pi, 768 plus, I'm getting approximately 901.97, and this is centimeters cubed. All right, and then our last example is, it's a cube. All 3 of the edges are the same, and then there's a cone that is removed. So the total volume here is going to be a cube and then subtracting a cone. The area of the cube is taking one of the sides and raising it to the 3rd power, cubing it. And then a cone is 1/3 the area of the base shape multiplied by the height of the cone. So the volume of the cube is 6 to the 3rd power, or 216. The volume of the cone is 1/3. The base is a circle, right? It's pi r squared. And the radius is going to be 2 because they're showing us that the diameter here is 4. So the radius is going to be 2. So I think that for the base shape, we'll have pi times 2 squared, which is 4. And then the height of the cone, I'm going to draw a triangle here to kind of show how we can find the height. Actually, the height of this cone, we can see the height is going to be the same as the height of the cube. So the height is going to be 6. So the height is going to be 6. So that is 24 divided by 3, which is 8. This is going to be 8 times pi. So I think our total volume is 216 minus 8 times pi. And if I plug in 3.14 for pi, I'm going to get approximately 190.88, and this is centimeters cubed. Okay, that's just a few examples for the volume of irregular shapes. If you have questions, send me an email or send me a message in Canvas. Thanks for watching.